Hi, hello students, good evening everyone. I hope all are doing well. If anyone is watching this particular live, just hit the like button here. Just mark your attendance by saying hi to me. Hi Arush, good evening. And I hope I'm perfectly audible and visible. Everyone please mark your attendance here by hit the like button. Hi Durgesha, good evening. Anyway, welcome to the Infinity Learned by Sri Chaitanya. This is Miss Surya, your chemistry mentor for this particular session. Okay, today we are going to, just for a change. Okay, today we are going to discuss a new chapter here, metals and non-metals. Okay, I have a question for you. What do you mean by metals or non-metals? Why we are studying about the metals and non-metals? Can you please give me an example of metals? Yes, they are electropositive, right? So in this particular session, we are going to discuss about the introduction part of the metals and non-metals. Then we are going to discuss about the physical properties. After completing the session, we will practice some questions also. Ready? Yes, iron is metal, copper, gold, platinum. Yes, very good, correct. Arush. Okay, they are electropositive, right? So let us see what are the classification of elements. Classification of elements. In our periodic table, we have seen that there will be 118 elements, right? 118 elements are present. Among them, these all elements can be classified into three broad classifications, right? Three broad classifications. What are they? Metals, non-metals and metalloids, right? Metals, non-metals and metalloids. Here in this particular chapter, we are going to discuss about the metals and non-metals very detailedly, right? Good evening, XYZ. Now let us see. Okay, these are just a picture representation for the metals, non-metals and metalloids. So, if you are seeing the classification of elements in the periodic table, you can say that, yes, correct. There are also noble gases as the fourth classification. But in general, these noble gases can be considered as a non-metal. Clear, Arush? Okay, only 7 people is watching, right? Mohammed Sahil, maximum share to your friends to join this particular session. Okay, as we can see over here, there will be a different color classification given here. I hope the picture is visible to everyone. Here, the blue color representation is represent the metals, right? Then those are representing, the green color are represented as the metalloids. Then the remaining yellow colors are represented as the non-metals, right? Okay, just think about that. What do you mean by a non-metal? What do you mean by a non-metal? In terms of electropositivity and electronegativity, we can say that the metals are electropositive, right? Electropositive, which can lose the electrons. In general, if you are taking any of the non-gases, right? Noble gases, we can say that they have the tendency to accept electrons. That's why they are considered as the non-metals here in general. Clear? Okay, fine. Now, how we can memorize these all elements? Is it possible? Hydrogen is both, right? Okay. Now let us learn a simple trick to memorize the non-metals first. Right? This is a simple mnemonic or the trick to find all the non-metals which is present in the periodic table. Right? Ready? So here, this is our first trick, SPONCH or sponge. S stands for sulfur. P for phosphorus. Then O for oxygen. N for nitrogen. C for carbon. Then last H for hydrogen. Arush, why yellow color is for hydrogen, right? Okay, yellow color represents the non-metals, right? When you are talking about the chemical properties of metals and non-metals, you will get a great idea about these. How these hydrogens are behave as a non-metals. Clear? Okay, fine. So this is a simple trick to memorize the non-metals here, including group 17 elements. What are the group 17 elements? Halogens, right? What are the group 17 elements? Please give me the names of group 17 elements, halogens. Right? These are the group 17 elements, halogens, fluorine, chlorine, bromine and iodine. There is one more element is present, astatine, that is considered as a metalloid. Clear? Arush, I hope you must have studied about the classification of elements, right? Periodic table, maybe in grade 9. Okay, fine. Then all the group 18 elements known as the noble metals are considered as the non-metals here. So we have already seen the trick to memorize the non-metals, right? Then what is all the elements remaining? These elements are considered as metals. One more example, that is some other elements are also present. Around 7 or 8 elements are present, that is known as the metalloids, which will show the properties in between metals and non-metals. So there is another trick to memorize these metalloids. Okay, fine. Helium, neon, argon, krypton, xenon and radon, right? Yes, correct. So this is another trick to memorize all the 8 or 7 metalloids. Let us see. This is a simple sentence. Send arsenic, tellurium and polonium live in boron's garden. Here you can see that some of the letters are capitalized, right? These capitalized letters are stands for the metalloids here. Let's see what are they. Right, the first letter S stands for 2 elements. What are they? First one, it is antimony, represented as the letter SB, seaborgium, right? Then again this S letter stands for another element, that is known as silicon here. Then the names itself suggests that another one is tellurium, then polonium, PO. B stands for here boron here, then G stands for germanium. Then the last one we have already discussed, that is astatine, right? Astatine. So these are the examples of all the metalloids present in our periodic table. I hope you understand. So what about other metals? All the metals excluding these metals, and all the non-metals are known as the metals, right? So just memorize these tricks to memorize the names of all the metalloids and non-metals. I hope you understand. If it is clear, give me a thumbs up in the comments. Okay, Arush, what is your doubt? Okay, let us talk from here. Okay, what are the halogens? Can you recapitulate with the groups and periods, right? So this is our periodic table classification. In here we can see that there will be some vertical groups, right? Vertical columns, you can see that. So if you are considering this complete periodic table, you can say that if you are starting numbering from here, right? If you are numbering from here, we can say that there will be 18 vertical columns are present in the periodic table, right? Those 18 vertical columns in the periodic table is known as the groups. So in a periodic table, we will have 18 groups, right? 18 groups. Similarly, if you are considering the horizontal rows here, you can say that 1, 2, 3, 4, 5, 6 and 7, right? I hope you must have idea about the block elements, S block, P block, D and F block elements. So here after these elements, this is the continuation of these 6th and 7th period elements. So in total we will have 7 horizontal rows known as the periods. Clear, Arush? So this is the classification of the elements in the groups and periods. Each group can be named into different groups here, but in the case of group 17, they are commonly known as halogens. Clear? Okay, we have one more chapter, I think classification of elements. We can discuss in detail in that chapter. Okay, there will be detailed chapter for that. SPD and F block elements we will be discussing later in the classification of elements in detail. Today we can discuss about the metals and non-metals, their physical properties. Is it fine? Yes. This is our modern periodic table. In some case it is shown that 1A, 2A, that is the old periodic table. Now we are using the modern periodic table only. So not need to consider about that. Fine? So I think we can move to our topic here. So we have finally discussed the memory trick to memorize the name of metals, non-metals and metalloids. Now let us directly move to the physical properties of metals and non-metals. We have to discuss these important topics here. First one is physical state, then malleability, luster, ductility, sonority and tensile strength for the metals and non-metals. Ready? I think we can start from the physical state of the metals and non-metals. Yes. As you can see over here, there is a broad classification, broad difference between metals and non-metals in their physical state. What are you observing here? At room temperature, the metals are crystalline solids except mercury, which is liquid at room temperature. In general, all the metals are solid in nature. Their physical state will be solids. But there will be one exception, that is mercury. Clear? So these exceptions are very important in your examination point of view, board exam point of view. Then, what about the physical state of non-metals? What about the physical state of non-metals? So, at room temperature, we can say that the non-metals are exist as either solid, liquid and gas, right? Okay, Arush, do you think there is any particular reason for that? Mercury is an exception. Mercury is a liquid. But I also don't have any idea about that. In general, mercury is liquid in nature, as you can see over in the clinical thermometers. Okay, in the case of non-metals, it can exist as both solids, liquids and gases, right? Here also you need to consider different examples also. So, carbon, sulfur and phosphorus are the solid non-metals. Then, liquid is only bromine, so this is very important. Then, in gaseous state, we can say that oxygen, nitrogen, chlorine are the examples of gaseous non-metals. I hope it is clear. So, in general, all the metals are solids in nature except mercury. But in the case of non-metals, they can exist as both solid, liquid and gases. You need to remember all the examples of different solid, liquid and gaseous non-metals. Okay, see, this is the mercury, this is the image of mercury which is present in the liquid state, and this is the bromine present in the liquid state here. And this is sulfur, again the mercury form. Okay, Harish, what do you think about that? Whether the liquid non-metal also gains electrons? In general, the property of non-metals are gaining the electrons, right? So just take an example, any of the examples, just think about that, whether it is gaining electrons, whether it is forming the electronegative elements, right? Then does mercury loses electrons? If you have idea about the mercury can be exist as Hg2 plus ions, right? Hg2 plus ions, which means that they are losing 2 electrons. Clear? Okay, now let us talk about the second physical properties of the metal and non-metals, that is luster. As we can say that whenever we are taking any of the metals, for example, if you are taking gold or silver, anything, we can say that there is a shiny surface, right? There is a shiny surface. That particular property of the metals is known as metallic luster. Clear? So, in the pure state of the metals shine when light strikes their surface. So, that shining property of the metals are known as luster, metallic luster. For example, gold, silver and copper are the examples of metallic luster or metals that are showing the luster property. Okay, what about bromine? Bromine also forming Br minus ion, right? How they are forming Br minus ion? By losing electron or gaining electron? Gaining electron, right? So again, there will be the property showing the electron negative character or the non-metal character, right? Clear? So what about the non-metals here? Is they showing any shiny surface or shining property? Arush, it is not possible to memorize all the metals. In periodic table, almost 75% of the elements are metals. So, it is very difficult to memorize all the metals. It is better to memorize all the metalloids and non-metals. And the elements which is except the metalloids and non-metals are commonly known as the metals. Clear? Okay. In general, the non-metals does not show any shiny surface, right? They lack luster. But exception is again there. If you are saying about the graphite means, I hope you must have seen about in the nib of pencil, that is a shiny surface, right? That is known as the graphite, which is the allotrope of carbon. So, exception is there, that is graphite, which is a allotrope of carbon, and another one is iodine. Iodine is also showing a shiny surface. Clear? Okay, as you are seeing about the periodic table, you can say that there is only particular staircase step-like model in which metalloids are present. So, it cannot be included in the noble gases case. Okay, these metalloids are showing the properties in between metals and non-metals. Sometimes it can act as metals, sometimes it can act like as non-metals also. Fine. So we have seen about the second property, that is the metallic luster. Generally, metal shows a shiny surface, that is known as the metallic luster. For example, gold, silver, copper. And in the case of non-metal, they lack luster. But there is an exception, that is graphite, pure allotrope form of carbon, and iron are the exceptions for the non-metals, which is showing luster property. Clear? So this is the image which is showing the luster property. Copper, silver, iron and gold. Then graphite, this is shown in our nips of pencil, and iodine, it is also showing the shiny property. I hope it is clear for everyone. Now let me move to the next property, that is known as the malleability. Malleability. What do you mean by malleability? What do you mean by malleability property? Yes, they can be drawn into thin sheets, right? They can be drawn into thin sheets. Such a property is known as the malleability. So, metals are the malleable substances. They can be drawn into thin sheets by hammering or applying any pressure. For example, aluminium, copper and iron. And another example is gold, right? We can make in jewelries. Then aluminium, copper and iron are the examples. Iron, gold are the examples of metals which is showing the malleable property. So oppositely, non-metal does not show any malleable character, right? So non-metals are not malleable. In fact, they break when pressure applied and hence they are brittle. Clear? So in general, the metals are malleable in nature. They can be drawn into thin sheets by applying a pressure over it. But if you are taking any of the non-metal, if you are applying an extra pressure over it, they will break, right? That property of the non-metal is known as brittleness. Clear? Okay, I hope it is clear for everyone. So this is the third physical property of the metals and non-metals, that is malleability. Okay, Manshi, what do you have to tell? Okay, same the image is shown here to show the malleable property of the metals and non-metals. So now let me move to the next property. That is the ductility of the metals and non-metals. Ductility of the metals and non-metals. What do you mean by ductility? Ductility. Just like the malleability, it is another property in which we can change the metals into their thin wires. In case of malleability, we can be changed or drawn into the metals into thin sheets. But here in the case of ductility, we can be changed into thin wires. Right? This property is known as the ductility of the metals. For example, again gold, tungsten, copper and iron are the examples of ductile metals. Clear? Yes, Arush, I also think like that. Just take an example of metalloids. Just show about the thinking about their valencies, how they are losing electrons or gaining electrons, right? Then what about the non-metals here? Non-metals are not ductile because of their brittle nature. Because when we are applying any high pressure on the non-metals, they can easily break, right? That particular property of the non-metals is known as the brittle nature. Because of this brittle nature, it will not be any ductile. It will not show any ductile properties, right? I hope it is clear. Okay, now let me move to the next property. We have seen 4 different properties for the metals and non-metals. Here is a 5th property, that is the tensile strength. Tensile strength. What do you mean by tensile strength? So metals have high tensile strength, that is they can withstand at high pressures. So this is the part of physics in which we can say that there will be stress and strain, right? So this tensile strength is the another part of the metals and non-metals. If you are applying a high pressure or high temperature over it, it can withstand with high pressure, right, without breaking. That particular property of the metals is known as their high tensile strength. High tensile strength. So examples are given here: zinc, potassium and sodium. They can be cut with knife also, right? So these are the tensile strength property of the metals. We can say that when you are applying a high pressure over it. When you are applying a high pressure over it, it can withstand the high pressure without breaking, right? Such property is known as tensile strength. So we can say that metals are having high tensile strength. Manshi, I don't get your question. So what about the non-metals here? Non-metals cannot withstand high pressure on conditions, right? Higher pressure conditions. But exception is there. Again, exception is there. Diamond. Diamond is another allotrope of carbon. Carbon is a non-metal. And diamond is another allotrope of carbon, which is one of the hardest element. Right? Clear? Manju, that's why I'm saying I didn't get your question. What was your question? Right. Okay, it's again based on the very depth knowledge of the chemistry, that is about the solid state. In case of diamond, there will be a strong strong force of attraction between the atoms in the carbon atoms in the diamond. So it can withstand the high pressure because of the strong bond in between the atoms. Now let us move to the next physical property of the metals and non-metals, that is sonority. Sonority. As you can see over here, whenever we are talking anything about the sonority, it will relate to the property sound, right? So if you are taking any of the metal, if you are struck it with a hard object, we can hear a small sound, right? We can hear a small sound. That property of the metals is known as the sonority. Sonority of the metals. That's why most of the times metals are used for ringing bells, used as ringing bells. Clear? Is that clear? So metals are sonorous in nature. So obviously, oppositely, the non-metals are non-sonorous in nature, which means that if you are struck with a hard object, it cannot produce any sounds, right? That property is known as non-sonorous property of the non-metals. So we have already seen about the sonority property of the Metals and non-metals. The metals are sonorous in nature, while non-metals are non-sonorous in nature. I hope it is clear. Now we will be moving to the next property, that is the density of the metals and non-metals. Density of the metals and non-metals. As we already know what you mean by density, right? Density can be taken as mass by volume, right? So in general, in case of metals, metals are very dense substances. Metals are very dense substances. Metals are very dense substances, which means they have high density because of their high or strong metallic bond in between them. So we will be discussing more detail about the bonds in the chapter of chemical bonding. So we will be seeing that ionic bonding, covalent bond. Along with that, there will be another bonding that is known as the metallic bonding, which is existing in between the atoms in the metals. So in case of metals, there will be a strong metallic bond in between them. That is why they are showing very high dense property, or they are having very high density, right? For example, you can say that here tin is having 7.28 gram per centimeter cube of density, and iron is having 7.9 gram per centimeter cube of density, right? Then again exceptions are there. In case of sodium, it will be 0.97 gram per centimeter cube, and for potassium it is 0.8786 gram per centimeter cube. Clear? Arush, in your examination point of view, you need to memorize all the properties. Along with that, you must be giving more concentration to the exceptional cases, right? Clear? Again, I am repeating, we need to focus on the exceptional cases more detail, right? You need to memorize all the density values for all the metals here. Only the exceptions are given, sodium and potassium, right? Less dense metals. Then, non-metals are having very low density. For example, phosphorus 1.82 gram per centimeter cube, and sulfur is having 1.96 gram per centimeter cube. Exceptions are there, iodine and diamond, that is the allotrope of carbon. These are having the high densities as compared to all other non-metals, right? So these are the again exceptions. So in general, we are considering the comparison of density by using the density of water at 25 degrees Celsius. So we are comparing the density of water with the metals and non-metals. Clear? Okay, I hope it is clear for everyone. Now let me move to the last property, that is the melting and boiling point of the metals and non-metals. Melting and boiling point of the metals and non-metals. So, as a regular pattern, metals are having high melting and boiling point. High melting and boiling point, right? So, we need more temperature to melt the particular metal here. Example is aluminium. Value is given here. Here M, smaller m stands for the melting point. Smaller b stands for the boiling point. Then iron is also given here. One more exception is here, that is mercury. As we already know, mercury is in liquid state, right? So they are having very low melting point of around minus 39 degrees Celsius. Clear? Then what about the non-metals? Non-metals is having very low melting and boiling point, right? Very low and melting point. So most of them, their values are lie below 0 degrees Celsius. Exception is carbon, because it is having the melting point of around 4000 degrees Celsius. Clear? Yes, it is better to memorize all the examples. If you are not able to memorize all the examples, at least take a reference on the exception cases. Arush, just think about why water is taken as a reference. It is the universal solvent, right? Universal solvent. So it is easily available. We can find out the density of water as a reference here, right? So far we have discussed about the physical properties of metals and non-metals. What we have seen already, physical state, right? Physical state. Then the next property, that is the thermal and electrical conductivity. Thermal and electrical conductivity. So in general, the metals are good conductors of heat and electricity. Good conductor of heat and electricity. We can pass electricity and heat through the metal properties here. That's why they are using in the kitchens, right? Kitchen utensils. Then, as we can see over here in your homes, there will be the electrical wires, right? In case of electrical wires, there will be a metal which is present, is known as a copper metal because of their higher conductivity towards the electricity. Clear? Then what about the non-metals? Non-metals cannot conduct electricity or heat. So they are used in the insulate handles of utensils. In order to insulate the handles of utensils and electrical wires. Then, again exception, graphite, that is allotrope of carbon, is an exception which can conduct electricity. For example, if you are taking the nips of the pencils, if you are putting a LED light here, we can say that there will be lighting happens, which means that graphite can conduct electricity, which is a non-metal. Exceptional case, in case of non-metal, graphite can conduct electricity. Is that clear? Is that clear? The first image is about the electrical wires. This is the handling, insulating powers of the handles in the utensils. Clear? Yes. So what we have seen today? We have seen about the physical properties of metals, right? Physical properties of metals and non-metals. We have discussed about the physical state of metals and non-metals. Physical state is about the, in case of metals, all are solids except liquid mercury, right? The non-metals are gaseous, liquid and solid state. So you need to memorize all the examples of non-metals which show in gaseous state, liquid state and solid state. Then what about the next property? Malleability. Malleability means we can draw it into sheets, right? So such property is known as the malleability. Then what about the next one? Luster. Luster property means which is showing the shiny surface, right? Shiny surface, that is known as the metallic luster. Non-metals are non-lustrous in nature. Then what about the ductility? How we can define ductility of a metal? How we can define the ductility of a metal? Again, we can draw it into thin wires, right? Thin wires. So ductility stands for thin wires. Then tensile strength, which means if you are applying a high pressure over the metals, it cannot break, right? It cannot be broken. So that particular property is known as tensile strength. Generally, metals having high tensile strength, non-metals having very low tensile strength. Right? Clear? Then last property, that is the sonority, right? Sonority. If you are struck with the hard objects, they can produce sounds, right? Sonority stands for sounds. So metals are sonorous in nature. That's why they are using in the ringing bells. Is that clear? Is that clear? Now let us practice some questions based on the physical properties of metals and non-metals. Here is the first question. Which of the following is true for aluminium? Which of the following is true for aluminium? Four options are given here. First one, it is a shining non-metal. Second one, it is a liquid metal. Third one, it is malleable and ductile. The last one, it is a liquid non-metal. What is the answer for this question? Always our regular timing is 5 to 6 only on Tuesday, Thursday and Friday for chemistry lectures. Okay, what is the answer for this question? Yes, malleable and ductile, right? So we have seen that aluminium is a metal, right? So aluminium is a malleable and ductile metal. Therefore, option C will be the correct answer. I hope it is clear for everyone, right? We cannot predict that it is a shining non-metal, as we already know. Aluminium is a metal, right? So the first one is wrong. Then liquid metal. Only mercury is the liquid metal, right? Then a liquid non-metal, it is also wrong. Now let me move to the next question. Here is the next question. Which of the following is true for iodine? Which of the following is true for iodine? Just let me know the answers in comments. Which of the following is true for iodine? Are you sure? So option A will be the correct answer here because iodine is having the lustrous property, right? Iodine is having the lustrous property. If you are giving a light to this particular surface, we can say that it will having a shiny purpose, right? So iodine is the only one non-metal which is showing lustrous property. So keep a note on that. Iodine is the only shining non-metal. So option A will be the correct answer here. Arush, is that clear now? Are you sure iodine is liquid, non-metal? So here is the next question. Which of the following is a hard non-metal? Hard non-metal. Okay, what is the answer for this question? Which of the following is a hard non-metal? Hard non-metal. Read the options carefully. First, you need to identify which one among the following is metals and non-metals. Okay, don't give any random guesses. Again, the earlier question it is discussed about the hard lustrous non-metal, right? So iodine is the correct answer here, option D. Iodine is the only one lustrous non-metal which is again hard. In general, all the non-metals are soft in nature, right? But this is the only one that is hard nature that is showing the non-metal. Clear? Okay, here is the next question. Okay. This is one of the questions asked in the CBSE exams. So, a metal and a non-metal that exist in liquid state at the room temperature respectively are. A metal and a non-metal that exist in liquid at room temperature. What will be the answer? First one is a metal and the second one is a non-metal which is in the liquid state. Ramya, are you sure? Option A. Okay, is there any other options? Yes, option C will be the correct answer because the question is asking about we need to find out the liquid metal and liquid non-metal respectively. So obviously the first one it is mercury. Mercury is the only one liquid metal and bromine is the only one liquid non-metal. I hope it is clear. So option C will be the correct answer here. Clear? Okay, now we are moving to the next question. Which one of the following metals is malleable and a poor conductor of electricity? Which one of the following metal is a malleable and poor conductor of electricity? As we already know, all the metals are conductors of electricity, right? There is only one metal which is a poor conductor of electricity. Which one it is? Okay, in order to answer these type of question, you need to keep a note on the exceptional cases. So in many of the examination, it will be asking about the exceptional cases only. So we need to focus on the exceptional cases. Clear? You can memorize the particular exceptional cases by using any of the trick or mnemonics. Okay, Arush, lead, right? So let us see what is the answer here. Yes, option C, lead is the correct answer, right? Lead is the only one metal which is malleable and pure conductor of electricity. I hope it is clear. Here is the last question which is based on the statement type question. There are 3 questions are given. First question, write 2 properties of gold which make it the most suitable metal for ornaments. Write down the 2 properties of gold which will suitable for making them as a property of the metal in the ornaments, in jewelries. Okay, what are the 2 properties? Yes, luster is a property, right? Because of the shiny surface. You can say that luster is one property. Then, hardness. How we can say that it is hardness is helping in the ornaments? Okay, you can add like that. Hardness is also property. Then main important property is the malleability, right? Malleability. It can be drawn into thin sheets. That's why we can make any of the gold ornaments like chains and everything, right? In thin sheets, wires. Then another property it is ductility. We can be drawn into thin wires, right? So you can write down any of the 2 properties of the gold which is suitable for making ornaments. Clear? Okay, even hardness is also fine. Clear? Then what about the next question? Name 2 metals which are good conductors of heat. Which are good conductors of heat. Okay, what is the answer for this question? Good conductors of heat. Okay, please give me answers fast. No answers? Okay, just take it as a homework. Then what about the next question? Name 2 metals which melt when you keep them on your palm. Name 2 metals which melt when you keep them on your palm, which means that which is having the very low melting point, very low melting point. In general, all the metals is having high melting and boiling point, right? There will be exceptions. That exception is asking here, name the 2 metals which is melted very low temperatures, or when you are keeping in your palm only, it will get melts. What is the answer for this question? Okay, one is gallium and another one is cesium. These are the two metals which is having a very low melting point. So gallium and cesium are the examples given here. I hope you understand. Clear? So that's all about from my side for today. We have already covered the introduction part of the metals and non-metals. What do you mean by metals? How we can classify the metals and non-metals. In the periodic table, we can classify all the elements into metals, non-metals and metalloids. And we have already seen some memory tricks to memorize the non-metals and metalloids. Those who are not containing all the metals and non-metals, they are known as the complete 75% of the periodic table is metals, right? So finally we have seen about the different physical properties of metals and non-metals like physical state, ductility, malleability, sonority, melting and boiling point of the metals and so on. So just keep a note on over the physical properties of all the metals and non-metals. Keep a specified note for the exceptional cases. In your board exams and competitive exams also, it is asking about the exceptional cases only. Clear? I hope you guys enjoy the session. If you really like the session, hit the like button, subscribe this channel and share this particular session to your friends also. So if you need the session PDF, you can join our Infinity Learn 9 and 10 Telegram channel. Okay, still do you have any doubt? Otherwise we can wind up the session for today. Arush, what suggestion required? Okay, this for chemistry learning, right? If you really subject any of the subject, it will be easy to learn. That is the only trick. First, you need to love the subject. Right? So I think we can wind up the session for today. Next, I will be coming back with the chemical properties of metals and non-metals. We will be discussing about all the chemical reaction with water, air, oxygen and so on in the next class. I mean, it will be in the Thursday, same time 5 to 6. So make sure that you will be attending all the sessions with me. Ready? Okay, thank you so much all of you. Bye-bye, take care.